Hello, welcome. Today we are here to see the question called maximum subarray from lead code. So question name is maximum subarray. What is the question name, guys? Question name is maximum subarray. Okay. So coming to the question, given an array numbers, given an integer array nums, find the subarray with the largest sum and return its sum. So they'll give us an array called nums. Okay, we need to find a subarray inside that where this has the largest sum. And whatever the largest sum is there, we need to return it. Okay, this is what the question is. I hope the question is clear to everyone. If not, just pause the video for a second and try to understand the question clearly. So let's go to the examples and see. This is your first example. So before we go for this example and all, what is subarray? What is subarray? What is subarray, guys? You guys see me 1, 3, 4, and 5. Let's say these are the 4 elements I have in my array. What is the subarray? Like now you guys see me 3 and 5. 3 and 5. Is this a subarray? Is this a subarray? No, this is not a subarray. This is not a subarray. So subarray means what is a subarray? Contiguous contiguous elements. Contiguous elements of an array. Contiguous elements of an array are called subarray. So if we take if we take any elements, those elements should be contiguous. Okay. So that is what subarray means. So in this example, this is one subarray. This is one subarray. Why this is one subarray? Because the elements are contiguous. And this is also one subarray. This is also one subarray. And this is also a subarray. This is also a subarray. This is also a subarray. Like contiguous elements are called as subarrays, guys. Just to be precise, contiguous elements in an array are called as or treated as subarrays. Subarrays. Now we need to find such a subarray. We need to find that subarray where its sum is maximum. Where its sum is maximum. We need to find out the maximum sum. Okay. Okay, that is what the question is. So given an example, let's see this example. -2, 1, -3, 4, -1, 2, 1, -5, 4. So this is an array. And now let's see. How many subarrays we have in this example, guys? What is this? How many subarrays we have? We have many subarrays. So this is a subarray. This is a subarray. This is also a subarray. This is also a subarray. So this is a subarray, this is a subarray, so on like this. And array is also a subarray. So in this way, if you take, we will be having around for one particular array. Okay, we'll be having some n square subarrays kind of thing. There is a formula for to find out the number of subarrays. I guess it is n into n minus 1 plus n minus 1 by 2. So that gives you an answer. That is the answer, guys. So it's like if you take this example, there are how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 elements. Initially, how many subarrays we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So for 9 elements, we got 9 as the first count. First count plus plus. If you take from this element, this is a subarray. This is a subarray. This is a subarray. This entire 1 minus 3 4, 1 minus 3 4 minus 1, 1 minus 3 4 minus 1 2. So in this way, if you take, it will be 9 plus 8 plus 7 plus till 1. So this total is called as sum of first n numbers. Sum of first n numbers. Okay. So that is what your formula is. It will be n into n minus 1 by 2. So that many subarrays we have. So what we need to do? So we need to find out the maximum subarray. What we need to find out? We need to find out the maximum sum subarray. We need to find out the largest sum for the subarray. Okay. Now coming back to the point, what we need to find out is the maximum sum. Okay. 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 Now, okay. I hope the question is clear, guys. I hope the question is clear. We need to find out maximum sum. Okay. For which one? For a subarray. So there are many subarrays here. This is one subarray. This is also one subarray. I'm not taking overlapping subarrays. I'm taking consecutive subarrays basically. This is a subarray. And let's take all these three with a summary. What is the sum of this one, guys? Sum is 1. What is the sum here? Sum is 1. What is the sum here? Sum is 1. What is the sum here? Sum is 0. What is the maximum value? These three are the maximum values. So if you take this pair, this pair, this pair, and this pair, the sum is 1. Okay, here also it is 1, guys. Sorry, my bad. It is, we have to count this one. So this is also 1. So if you take all the elements got the same sum. If you take in pairs. Now there are overlapping subarrays also. If I take another color, this is also a subarray, right? 2 minus 2, 1 minus 3. The sum is somewhere around minus 4. Okay. If I take one more element added, the sum will become 0. If I take one more element added, sum will become minus 1. So in this way, we have many subarrays, right? We need to find out sum. So the coming back to the approach, coming back to the question. Okay, let me take an example. 1, 2, 3. 1, 2, 3. This is my array. How many subarrays I'll have, guys? How many subarrays I'll have? It will be 3 into, so the formula is n into n minus 1. N into n minus 1 by 2. Okay. If we apply the same formula here, n is 3. N is nothing but the length of the list. N is 3. 3 into 3 minus 1, which is 2. 3 into 2, 6. 6 by 2, 3. So there are 3 subarrays in this particular array. So now let's see whether this formula is correct or wrong. 1 is itself as a subarray, 2 itself is a subarray, 3 itself a subarray, 1 comma 2 is also a subarray, 1 comma 2 comma 3 is also a subarray, and 2 comma 3 is also a subarray. So this is not the correct formula. I guess it is n into n minus n plus 1. I think it is n into n plus 1, guys. Okay, 1, 2, 3. Okay. So if we apply this formula, what will be the value? N is 3. 3 into 4, 12. 12 by 2, 6. Okay. How many values we got? 1, 2, 3, 4, 5, 6. Okay. So this is the formula. So it's my bad. It is not minus, it is plus. So if we take any array, we will get n into n plus 1 by 2 subarrays. Okay. That is okay. Fine. Now we got all these subarrays. What we need to find out? What is the maximum sum for the subarrays? If we take the first subarray, what is the sum? What is the sum? What is the sum, guys? What is the sum? Sum is 1. If we take the first subarray, the sum is 1. Okay. Okay. Sorry, guys. So what is the sum of first subarray? Sum of first subarray is 1. Okay. Is it a maximum sum? Oh, yes, there can be a possibility. It can be a maximum sum. Okay. What is the sum of my second subarray? Sum is 2. Okay, now sum is 2. What is the maximum sum? 2 or 1? Which one is the maximum sum? Obviously 2, right? I have an update with 2. Now what is the next subarray, guys? Next subarray is 3. It has only one element, 3, and the sum is also 3. The sum is also 3. Now what will be the maximum value? 2 or 3? Which one? 3. 3 will be the maximum value. Now let's take one more example. 1 comma 2. This is one more subarray. 1 comma 2. What is the sum of 1 comma 2? Obviously, sum is 3 again. Sum is 3 again. What is the maximum value that we have? 3. 3 is the maximum value. Both are same, so don't update it. What is the next subarray? 1 comma 2 comma 3. 1 comma 2 comma 3. What is the sum here? What is the sum here? Sum is 6. Sum is 6. What is the max value now? 3 or 6? 6. 3 or 6? 6. Okay. What is the next subarray? 2 comma 3. What is the sum of the subarray? Sum of the subarray is 5. 5. Which is the maximum value? 6 or 5? 6 or 5? Obviously 6. So this will be your answer. 6 will be your answer. Okay. This is your maximum sum. So this is what we need to find out. So we need to find out maximum sum for a subarray. Maximum sum for a subarray. So the brute force or the basic way to do is generate all the subarrays like this and calculate sum of each subarray and check whether it is a maximum sum or not. Check whether it is a maximum sum or not. If it is not a maximum sum, if it is a like whatever the maximum sum you got, return that maximum sum. Return that maximum sum. Okay. I hope this is clear. I hope this is clear. So this is the brute force approach, guys. What is the brute force approach here? Generate subarrays, all the subarrays. Now, for every subarray, calculate the sum. Now, every subarray, calculate the sum. Now, compare this sum with the maximum sum. If it is maximum, update. If not, leave it. Do this for all the subarrays. That's all. That's all, guys. This is what your brute force approach is. And what will be the time complexity here, guys? What will be the time complexity here? What will be the time complexity, guys, here? I want an answer. What will be the time complexity? Think, think. What will be the time complexity to generate all the subarrays? So, time complexity to generate all subarrays is big O of, okay, big O of, sorry. So, the time complexity to generate all the subarrays is, it is big O of 2 power n, 2 power n, because when you are generating, okay, when you are generating, okay, this is not, sorry, subarrays, right? So this is not correct. Sorry, my bad. Okay, sorry. So the time complexity to generate all the subarrays, it will be n square, n square. So we'll go to every element. This element itself is a value, which is a subarray. We'll take another two elements. Next, we will take all the three elements. So the time complexity, the least time complexity that we can use to generate the subarrays is n square. Okay, the least complexity that we can use to generate the subarrays is n square, guys. But if we go with the naive approach to generate this subarrays, naive approach, which means very basic approach, it will be n cube, n cube. So you can ask me, sir, what is this n cube and n square? How you got this? So basically, if you take a very basic way to generate subarrays, it will be n square, guys. So you can convert this, you can reduce this to n square. You can reduce this to n square. You can reduce this to how much? N square. How you can reduce? By adding the previous value, by taking one simple variable, okay, that is called as, you can call it as a prefix some variable, and you can use it anyways. Okay, now I'll tell you why this is n cube first. Why this is n cube first? So if you take 1, 2, 3, so we are running a for loop. We are running a for loop called I. Okay, I loop is running. I is at currently at 0th index. Now for this element, I need to, for this index, I need to find all the subarrays. So what are the subarrays possibles, guys? This is one subarray. This is one subarray. And this is one more subarray. This is one more subarray. Okay, I am at 0. So I need to go from 0 to, I need to go from 0 to, okay, I need to go from 0 to 0 for the first time. After that, 0 to how much? 0 to 1. After that, 0 to how much? Where I need to go? 0 to 2. Okay, this is your way. You are at index 0 and you need to go from 0 to 0, 0 to 2, and also 0 to 1. All the possible subarrays. You need to generate all the possible subarrays. So internally, it takes this time complexity. Okay, I hope this is clear. So simple way, simple approaches: generate the subarrays, calculate sum of each subarray, If the sum is maximum sum, update it, else leave it. So this is what your basic approach is. Okay. Now let me take you to one more important approach. This is your optimal approach, you can call. Or this approach, basically this approach, how we get this approach is, there is an algorithm called Kadane's algorithm Kadane's algorithm Kadane's algorithm. Okay, there is an algorithm in arrays which is called as Kadane's algorithm, guys. Kadane's algorithm. So I'll explain you this example. I'll explain you this algorithm with an example. So let's take an example, guys. Let's take an example. So let's say we have an array called nums array. Okay, let's take 2, -1, 3, 2, 0, not 0, -1 or 2, 4, 5. Okay, now here let's take 3. Now from this particular example, -6. From this example, guys, what is the maximum sum subarray you can get? Guess. What is the maximum sum subarray you can guess, guys? Just pause the video for a second. Do it manually by generating all the subarrays. Okay? Okay. I hope you are doing this. You did this. So the maximum sum subarray here is this is the maximum sum subarray. This is the maximum sum subarray. So what is the sum here? 4 plus 5, 9. 9 minus 2, 7. 7 plus 3, 10. 7 plus 3, 10. So this is the maximum sum subarray. This is the maximum sum subarray. So subarray should be contiguous. Subarray should be contiguous. Okay. Okay. Now Now let me take you through the Kadane's algorithm, guys. So Kadane's algorithm has very basic steps, guys. So what we are doing, we are finding the sum. Okay, we are finding the sum. So let's say we have calculated a sum of these values. Sum of these values. Sum of these values. What is the sum of these values, guys? 2 minus 1. 1. 1 plus 3. 4. 4 minus 1. Minus 2. Let's say we have calculated the sum of these values. This is -2. Now, when you now if you want to calculate this particular subarray sum, is it necessary to calculate? Just think, is it needed? Because this itself give -2. This itself give -2, which means if you add -2 plus 3, it will give a very worst value. This is 1. 1, you will get 1, which is not better than this individual element, right? If you just understand this clearly, guys. So what is the subarray that we have taken? Let's say this is the subarray that we have taken. What is the sum of this subarray? Sum of this subarray is -2. Okay, now let's add one more element and we will calculate this subarray, this entire subarray sum. Now what will be the entire subarray sum? It will be -1, sorry, +1, +1. Now if you don't take this element, it is -2. If you take this element, it is +1. But what is the actual element? Actual element is 3. Which is the better option to choose here, guys? Which is the better option? So the better option is to choose this 3. To choose this 3. You can ask me, sir, why? Because what we are finding for the maximum one. We are finding for the maximum one. So when you encounter a negative value in the sum, okay, when you encounter this negative value, then simply make this as 0. Make this as 0. Assume there is nothing is there previously. Assume there is nothing previously, and this is your first element. This is your first element. So now what will be the value you'll get? 3. Compare this with the maximum subarray and update it. Isn't it clear, guys? So what is your Kadane's algorithm says is, let me take you through the Kadane's algorithm guys again. Okay, I hope this previous thing is clear. Just to add to those, I'll take you through. What does this Kadane's algorithm say is, start from the beginning. Start from the beginning. Add all the elements. Add all the elements. What we need to do? We need to add. What we need to do? We need to add. Okay. When you are adding, okay, when you are adding all the elements, okay, when you are adding all the elements, if you encounter a negative value, if you encounter a negative value, if you encounter a negative sum, basically sum, not a value, negative sum. So when you are adding, you will maintain a variable called sum. When you encounter this negative sum, okay, assume, okay, when you encounter this negative sum, so assume there is nothing happened till now. There is nothing happened till now. So let's take S is a variable where it will store the sum. Now, if you have encountered the sum is -2, okay, you are iterating on this array. When you are at this particular -6, the sum is -2. The sum is minus 2. So when you encounter this negative value, when you encounter the negative sum, basically negative sum, assume there is nothing and make this as 0. Make this as 0. Assume there is nothing previously. This is a start. Okay, this is what the assumption is. So what does Kadane's algorithm says is, when you are adding the elements in the variable called s, whenever this value turns into negative value, okay, assume there is nothing previously. Assume there is nothing previously done, because there is no use of carrying this forward. Why? Because if you add a positive value to the negative value, whatever the value you may get, this will be less than this positive value itself. That value will be less than positive value itself, right? Obviously, yes or no? Let's say there is minus 1, guys. Minus 1. If you add 10 to this minus 1, what is the value you'll get? 9. Isn't this 9 less than 10? Isn't it 9 less than 10? If 9 is less than 10, what is the point of adding this minus 1? What is the point of adding this minus 1? Okay, is this clear, guys? Are you getting this? Basically, when you are going forward, whenever you get encountered the negative value, simply leave this. Simply make it as 0. That is what your Kadane's algorithm is. Okay. Now let's go through this example from the beginning, guys. Go through this example from the beginning. Okay. Okay. I am at where I am at. I am at index 0. Let's say sum equals to 0. My maximum sum. There is two things, guys. There I should find out the maximum sum. My maximum sum equals to uh let's say minimum value. In the entire integers. What is the minimum value in the entire integers? How you can find out this minimum value? There is a thing called integer dot min value in your Java. So you can use that one, integer dot min value. Okay, that is the secondary. So my sum is 0, my max sum is minimum. Okay. Now I'm at index 2. Sorry, index 0. Index 0, which is value 2. Now I will add this value to my sum. This will become 2. Which one is bigger one? 2 is big or minimum value is big? 2 is big or minimum value is big? Obviously 2 is big. So update this minimum value with 2. Okay, nice. This still is clear, right? Okay. Now I'll go to the next index, which is 1. Now, what is the value at index 1? Minus 1. Add this minus 1 to the sum. What will be 2 plus minus 1? It will become 1. Which one is bigger? 1 is big or 2 is big? Obviously 2 is big. So let's continue further. What is the next index, guys? 2. What is the next index? 2. What is the value that we have? 3. Add this 3 to your sum. 1 plus 3. It will become 4. 1 plus 3. It will become 4. Which one is bigger one? 4 or 2? Obviously 4. Update this maximum sum with 4. Okay. Till now everything is clear, right, guys? Okay. Now let's jump into the next one. Next index is 3. What is the value we have at index 3? Minus 6. What is the actual sum that we have till now? Sum is 4. 4 plus minus 6. 4 plus minus 6. What is the value? Guys? What is the value you will get? Minus 2. What is the value? Minus 2. When you got this minus 2, will this become a maximum value? Obviously no. And whenever you got this negative value as your sum, so this will be updated with minus 2. Okay. Now, when you got this as minus value, according to the Kadane's algorithm, what does it mean? Whenever you get a negative sum, update this negative sum with 0. Why we are updating the negative sum, guys? Why we are updating this negative value with 0? Because instead of carrying the negative value to the further part of the array, it is better to carry 0, because if you carry negative value, what happens? Even though if you have a big positive number, even though if you have a big positive number, if you add this big positive number to the negative value, the resultant value will be obviously less than big positive value, right? Which means the sum will be reduced. So that is the reason, guys. I hope this reason is pretty clear to everyone. Now let's move on. Whenever you get -2, what I need to do? I need to update this with 0, 0. Okay. Now what is the next value? Next value is 3, which is at index 4. 0 plus 0 plus 3. 3 is big or 4 is big? Obviously 3 is big. Obviously 3 is big. Now I'll go to the next index. What is the value at next index? -2. What is the value at next index? -2. 3 plus -2, what it will become? It will become 3 plus -2, it will become 1. 3 plus -2 become 1. So which one is bigger one, guys? Which one is bigger one? 1. 4 is the bigger one. 4 is the bigger one. Okay. Now let's go to the next value. What is the next value? 4. 1 plus 4, what it will become? 1 plus 4, what it will become? It will become 5. Which one is bigger one? 5 is big or 4 is big? Obviously 5 is big. Update this maximum sum with 5. Update with maximum 5. Maximum sum with 5. Okay. I'll go to the next element. What is the element, guys? What is the value here? 5 again. 5 and 5. It will become 10. It will become 10. Which value is bigger? 10 big or 5 big? Obviously 10 is big. Obviously 10 is big. After that, do we have any values? No. We reached the end of the list. After reaching the end of the list, whatever the value your maximum sum have, that is the answer. That is the answer. And this is what your Kadane's algorithm is. This is what your Kadane's algorithm is. So basically, your Kadane's algorithm is iterate on array, iterate on array, iterate on array, okay, and add each element to some variable. Add each element to some variable. Okay. After that, what you need to do? If sum is negative, update with 0. If sum is negative, update with 0. After that, if sum is greater than maximum sum, update max sum. Update max sum. That's all. Pretty simple 4 steps, guys. When you are iterating on the array, these 3 steps comes into picture. Add each element into some variable. If sum is negative, update with 0. If sum is greater than max sum, update the maximum sum. That's all. That's all, guys. And at the end, return the max sum. Return the max sum. Return the max sum. What you need to do? You need to return the max sum. Max sum you need to return. I hope this is clear. Now let's jump into coding part. Let's code this. Same thing, whatever that we have discussed, guys, I'll be coding here. So let's take two variables, int sum equal to 0 and max sum equals to, as I said, integer dot min value. Min value, as I said, we'll be taking the minimum value. Now let's iterate on the array. Int I equals to 0, I less than nums dot length, I plus plus, I plus plus. Okay, okay. Now, after going to every value, what I need to do? I need to add sum plus equal to nums of I. Sum plus equal to nums of I. Okay. If my sum is less than 0, if it is a negative value, update with 0. Update with 0. Else, if my sum is greater than max sum, if my sum is greater than max sum, update my max sum to sum. Update my max sum to sum. And then what I need to do? I need to return sum. Sorry, I need to return max sum, guys. Don't return sum because it might have a least value too. So return your maximum. First step is iterate on the array. When you are iterating on the array, add the value, current value to the sum. If the sum is negative, make it 0. If sum is greater than maximum, update the maximum. And then return your maximum. Let's run this. Let's run this. Let's see. That's all, guys. This is your Kadane's algorithm. One of the important question, guys. Try to understand the logic. The steps are very simple, but why we are adding, why we are making it 0, why we are updating the maximum, this is very important. I have clearly explained this particular part, why we are making 0, because we should not carry the negative value to the next part of the array, which makes the next part of the array a more less. That's all. I hope you enjoyed the video, guys. Thank you.